So here we have a 0.5 kilogram mass stationary ball. Initially, it is being kicked towards the wall. The initial speed of the ball after the kick is 19 meters per second and the ball doesn't rotate. The player's foot is in contact with the ball. So the time duration is given 55 milliseconds, and we need to figure out the average force that acts on the ball due to the football player. So the way to do this is using the impulse momentum theorem, which states that J is equal to F delta T is equal to change in the momentum. That's the impulse momentum theorem. Since we need to figure out the force, so let us make F as the subject. So force will be equal to delta P divided by delta T, where T is the time of contact, which is given to us as 55 milliseconds. So for delta T, let us write 55 and we need to convert that into seconds. Now change in momentum is final momentum minus initial momentum. So we need to figure out what is the final velocity and what is the initial velocity. So in the question it was mentioned that initially the ball is stationary. So initial velocity we will take as 0 and the speed of the ball after the kick is 19 meters per second. So 19 is the final velocity. So in change in the momentum, we will write m. M is the mass and mass was 0.45 kilograms. So we will write 0.45, which is the mass. And then we have final velocity minus initial velocity. Final velocity being 19, initial velocity being 0. And let's try to simplify this. So we will write F is equal to 0.45 multiplied by 19, that is the numerator. And in the denominator, we will write 55 into 10 to the power minus 3. And if we solve this, we will get 155.45 Newton. And that is the average force that acts on the ball due to the football player. A tennis ball is hit with a racket from a point 1.5 meters above the floor. The ceiling is 8 meters above the floor as shown in the diagram. The initial velocity of the ball is 15 meters per second and the angle is given as 50 degrees. We have to figure out the mean force which is exerted by the racket on the ball if it is mentioned that the tennis ball was stationary before being hit. So the mass and the time of contact is also given. So how do we figure out the mean force? We will again use the impulse momentum theorem. J is equal to F delta T is equal to delta P. So let us try to make F as the subject. So we will get change in the momentum upon time. Now the time of contact is mentioned in the question as 23 milliseconds. So be careful. We are supposed to convert that into seconds. So the factor of 10 to the power minus 3 is very important. Now change in the momentum is m into final velocity minus initial velocity. Initial velocity is 0 since the tennis ball was stationary before it was hit. And the final velocity after the racket hits the tennis ball, the velocity is 15. So let us put all the values in. For change in the momentum, we will write m into v final minus v initial. Mass is 5.8. Let's write this down. 5.8 into 10 to the power minus 2 multiplied by final velocity is 15, initial velocity being 0. So 15 minus 0. And let's try to simplify this. In the numerator, we will write 5.8 into 10 to the power minus 15 into 15 divided by the time taken. And if we simplify this, we will get 37.826 newtons. And if we need to round this off to two significant figures, we can write down the force is approximately 38 newtons, correct to two significant figures. Now, in the second part of the question, we were supposed to explain how the Newton's third law is applicable when the racket hits the tennis ball. So Newton's third law, we remember, is the action and reaction pair. Forces are always in pairs. So if object A is exerting a force on object B, so object B will also exert the same force on A, but in the opposite direction. So magnitude is the same, directions are opposite. So how do you write that in statements? This is the official answer. So the second part of the question, how do we start? First, in the magnitude. So force of the ball on the racket, that is equal to the force of racket on the ball. And the value we had figured out was 38 Newton. So this was magnitude. Now the direction. The ball exerts a force in the opposite direction to the force of racket on the ball. In other words, let us draw a diagram. Let's say this is a racket and we have a ball. So if the racket is giving a force to the ball in the rightward direction, so the ball is going to provide a force, same force on the racket, but in the opposite direction. Remember, in the Newton's third law, magnitude of forces are the same, direction are opposite, but most importantly, both forces act on different objects. Some students make this mistake of keeping both forces on the same object. That will violate the Newton's third law, which states that the two action reaction forces should be acting on different objects. So, in the second part of the question, player B intercepts the ball when it is at its peak height. Player B holds the pedal stationary and vertical, like as shown in the figure. The ball is in contact with the pedal for this many seconds. So, time of contact is given. Assume the collision is elastic. We need to figure out the average force which is exerted by the ball on the pedal. Since we have to figure out the force, so we again go to the impulse momentum theorem. J is equal to F delta T, which is equal to change in the momentum. Since we have to find F, let us make F as the subject. So we'll get delta P upon delta T. Now, delta T is the time of contact, which is given as 0.01 seconds. For the change in the momentum, we have m into final velocity minus initial velocity. Initial velocity of the ball is mentioned 10.5 meters per second. To find the final velocity, we have to use this fact that the collision is elastic. So, since the collision is elastic, the incoming speed and the rebound speed will be the same since the kinetic energy is conserved. So, the rebound velocity will be 10.5 meters per second only, but the direction will be towards the left hand side. So, the final velocity is 10.5, but since it is towards the left hand side, we will put a negative sign. So, in the bracket, we will write negative 10.5 minus initial velocity is 10.5 towards the right, so it is positive 10.5. And we have the mass. What's the mass of the ball? It was 2.7 grams. So instead of m, we will be writing 2.7 into 10 to the power minus 3. And if we solve this, now let's put the value of delta p in this expression. So force will be equal to delta p upon time. Delta p is 2.7 into 10 to the power minus 3. In the bracket, we have minus 10.5 minus 10.5, which will be a negative 21 divided by the time taken. Time of contact is 0.01 seconds. So if we simplify this, we will get the value of force as negative 5.67 newtons. So minus sign only represents the direction leftward. So the magnitude of force will be 5.67 newtons. In the third part, we have to explain why the egg is likely to break when dropped onto concrete from the same height. So we'll have to use the same impulse momentum theorem. The J is equal to force into time. Now, since we have to prove that the egg is likely to break when dropped onto concrete, which means the force which the concrete is providing to the egg is much larger than as compared to the ground. So how do we prove it? So the value of F delta T is equal to change in the momentum, which is equal to m final velocity minus initial velocity. Now, since the egg is supposed to come to rest after hitting the surface, so final velocity is 0. Let's write that down. And initial velocity is the velocity of the egg just before hitting the surface. And in the previous case, we had figured out the value of that V to be 4.64 meters per second. So V initial is 4.64. So if you analyze, the right side of this expression is the constant because m, final velocity, initial velocity are all the same no matter what the surface is. It could be the ground or it could be concrete, but the initial velocity and the final velocity are the same. So the right side of this expression is a constant. So we can write F delta T is a constant for both cases, concrete as well as ground. Now, since F into delta T is a constant, we can write force is inversely proportional to time. Now, try to visualize when the egg hits a concrete surface versus a egg hits the ground. The time taken to come to rest will be greater in which case? See, concrete is a lot harder surface, so the egg will come to rest in a very short amount of time. So, we can write that the time taken in case of concrete, the time taken for the egg to come to rest when it hits the concrete will be much lesser than the time taken in case of the ground. So T concrete is less than time of the ground. Since force is inversely proportional to time, we can now deduce that the force in case of concrete will be greater than force in case of ground. So let me repeat. According to this deduction, the force which the egg experiences because of concrete, that will be much larger as compared to the force which is acting on the egg due to the ground. That is why when an egg hits a concrete surface, because the force is large, it is much likely to break in case of concrete as compared to the ground. And that's how we solve this question. Let me repeat what we have done. Initially, we proved that the right hand side, which is delta P, is constant in both cases, concrete as well as the ground. Since the right hand side is a constant, we can say force is inversely proportional to time. And that is the approach we use to solve this question.